offline quality control is mostly about the design part. So we are not focusing on the design. We are focusing on the second part, which is online quality control, or you can say while the production is going on, we do this type of control. It is also called as statistical quality control or statistical process control. So we'll start with the second type. Statistical process control. Now, in the statistical process control, we will be talking a lot about statistics and related methods, sometimes probability and all. So, what we know, what is the meaning of statistics? Anyone? So, anyway, it's a very basic term which we often use in our regular day-to-day talks. So we can say statistics is a science that deals with the collection, classification, analysis, and making inferences from data. The main components in the statistics are collection of data, classification, analysis, and making inferences finally. Okay, so basically, there are two types of statistics that we often see. We see descriptive statistics and inferential statistics. Descriptive statistics is very simple. If I ask all of you guys to tell me how many hours do you sleep, okay? So every one of you are going to give me some response. Let's say some of you tell me that you sleep for 4 hours. Some of you are going to say 5 hours, 6 hours, 7 hours, 8 hours, and let's say 9 and 10 hours. I don't think. Uh, so when I'm asking question like this, how much time do you sleep in a day? So it is implied over here that I'm talking on an average. Hmm. So you give these answers, and then correspondingly I make a frequency distribution of this. So number of students sleeping for 4 hours are, let's say, five students. Number of students sleeping for 5 hours is, say, 10 students. Number of students sleeping for 6 hours is, let's say, 12 students. Then let's say 7, 15, again 8, 15, 15 students, again here you 10 students, say 8 students. So how many total? What's the total?
So 70.
That makes it, let's say 70 students are there in a class, and we get this frequency. So this is what you say is frequency. Okay, and I can also find out average of it. What is the average sleeping time of the class? 70 divided, how many, can anyone find out the average? How do you find out average?
So 10.
5 students sleeping for 4 hours plus 10 students sleeping for 5 hours plus 12 students sleeping for 6 hours and so on, divided by 70, right? So what average do you get? Can you tell? Yes, what's the average?
So 7.6.
7.67.
7.6 hours is the average sleeping time of the students in the class, given class. So I can find out the average. Now, if I have to claim that students in the age group of students, or you can say engineering students in you people are in fourth year. In fourth year, sleep for 7.6 hours. These kind of statements you often see in newspapers also. Okay, so uh, if I'm if I'm trying to what I'm trying to do over here is I'm trying to generalize this statement for all the fourth year students. So what's the difference between this 7.6 and this statement over here? Can you tell me what's the difference between the two statements? Anyone? See, this seven. How did I get this 7.6 hours? I took a sample. I went to a class and found out, or I interviewed 70 students and then found out. And from that, I am saying that all over India, engineering students of fourth year they sleep for 7.6 hours. So this is a descriptive data. Okay, this is you can say this has been derived from a data straight away as it is a very good evidence. But then I want to generalize this evidence. I want to make an inference from this evidence regarding the whole population. So that is called inferential statistics. So as long as we are talking about descriptive statistics, which contains terms like mean, median, mode, standard deviation, like these terms, then we say it is a descriptive statistics. So descriptive statistics describes the characteristics of product or process using the information collected on it. So it is like a face of a person. By looking at the face, you just can't make out whether the person is friendly or non-friendly. You talk to him after some time and then you make a conclusion out of that. So descriptive statistics is just like face of the data. You can watch the data, but in order to make a conclusion out of the data, in order to make a conclusion means in order to take out something meaningful out of data and then generalize it for the whole population, then we say it is inferential statistics. And how it is related to quality? Anyone can make a guess? How is it related to quality or online quality control? Yes, Jaswant, Shubhangi.
So it can be used to describe what's the quality overall from the data.
Okay. Any Janvi, Karan Pratap,
Um,
anyone?
Sir, I think we can tell like from the total number of products which are manufactured, how what's how many are of good quality and what's the problem error, like something like that.
Very good, very good. So it's like I want to make a conclusion about myself. because I can't check the whole production. Okay, there are many products being manufactured on per minute or per hourly basis, and there may be many things associated with that. So I can't invest that much time and money in checking every single object. So I can draw samples, and then I can um, make some observations with the descriptive statistics, and then I can try to generalize it for this lot which is being manufactured. So there I'm going to use the inferential statistics. Okay. So how do I collect the data? Data can be collected by direct observation or through questionnaires. You can do that. And see, now there's a term called random variable. Can you make a guess what will be the meaning of random variable?
So the variables which come into picture due to random events in the process.
Okay. Anyone else? So let me clarify this. Right now, let's say light goes. You're just studying right now, and suddenly the light goes. Okay. So this is certain event which has happened. Now, is does this have a pattern behind it? It may have a pattern behind it. It may or may not have a pattern behind it. So, question one. Second question, let's say, what is the speed of the wind right now? Or let's say we talk about temperature, because in northern India it is very cold right now. So let's say we talk about temperature at a given place. Now this temperature maybe, I mean, if you look at your application right now, the weather application, it may be showing some temperature. Okay, uh, 13 at my place it is showing 13 degrees centigrade. Okay, now is it definitely going to be 13 degrees centigrade? I may have to check it. Uh, Similar, now this temperature may actually not be exactly 13 degrees centigrade, but somewhere around. Similarly, uh, most of the things in the life, or most of the things in the nature that we look around, they follow a sort of a pattern. Okay, we call that as a random variable. That pattern, which the variable that describes the pattern, is a random variable. Like leaves fall from the tree, right? Leaves, there's a tree like this, okay, and leaves are falling from the tree all around. Okay, so you might see a sort of a pattern over here, or if you look at the pattern from the top, you may find here, if here is the tree, and you draw a periphery around the place where the leaves are falling, you might find this kind of a pattern. Okay, now a leaf which is falling from the tree just right now may fall here, may fall here, may fall here, depending on the air which is blowing, and depending on the mass of the leaf, depending on the geometry of the leaf, profile of the leaf, it may fall at certain place. But then the location of the leaf, or we can say, if you want, we want to make it graphically. Uh, if let's say this is the mean which is representing the center of the tree, so you may find that leaves are falling in a normal distribution around the trunk of the tree. Okay, like distribution. Some, and on x-axis you have distance. So if this is mean, the leaves may be, so here the number of leaves you can find out, the frequency you can make. So obviously the number of leaves will be more near the trunk of the tree, and lesser and lesser as you go away from the trunk of the tree. So you may find that as a normal distribution. Similarly, air, the flow of the air around a region. So similarly here, air which is flowing, let's say the speed is 15 kilometers per hour at a given place, mean. So it may be distributed across. Now we find out the for 30 days we collect the data, hourly data, and we eventually will find out the data is distributed like this. Speed of the wind is distributed like this. Similarly, you can also observe that the waking up time of you is distributed like this. Now, can you guys tell me some activity which you do during day, and you do it so many times that you can make a frequency distribution of that? Anyone?
Drinking water.
Huh? This one, yes.
Drinking water.
Drinking a water. So, but then let's say what you were saying is the frequency distribution of drinking water. So, on a let's say today, how many glasses have you drunk? Maybe you have taken 6 glasses, right? So you can't. So you have to, in order to make frequency distribution, you have to make it per hour in a day. Then only. For example, I'll give you one thing. Let's say beats per minute. Okay. So beats per minute data you must be having. Most of you, if you are wearing smartwatch, you will get that data. So if we say beats per minute, so you take the observations every 5 minutes. Let's say you find out what is your beats per minute in a day. How many minutes are there in a day? How many 5 minute intervals will be there in a day?
So 288.
Huh?
So 288.
288. Okay. So you make 288 observations in a day. And then you can draw this frequency distribution that, okay, 72, 71, 70, or it may go up to 90 and all. Then you can make a frequency distribution and then you can find out how your beats per minute are distributed in a day. Okay, so this is, so here in this case your beats per minute is a random variable. Okay, similarly, let's say number of minutes spent on phone per 5 minutes in a day. Number of minutes spent on phone per 5 minutes. Do you think it makes relevance in 5 minutes? In every 5 minutes, how much time do you spend on a phone? Because you admit it or not, most of us are addicted to just opening the phone for no reason, or it has become a involuntary action from your side. You're just going to check it, put your fingerprint on, and then you're going to open the WhatsApp and you're going to check it. Okay, maybe 30 seconds you spent and then they close it. Another 5 minutes you again spend some seconds on it and then they close it. Sometimes whole 5 minutes are going in that. Okay, so you can make that observation as well. So you can, so here in this case, what is the random variable? Yes, what is the random variable in this case? Yes, Varun? Suryansh? Shubhangi? So in this case, the random variable is number of minutes you are going to spend on phone per 5 minutes. This is the whole random variable, and it may be distributed like this. Okay. So the random variable is a variable which takes any value in a given range, but randomly and follows a certain pattern. So we can say random variable follows a pattern in a given range. So in that sense, random variable is actually not very random, or it's sort of a misnomer. It is it is a variable which takes value in a given range and follows a certain probability distribution, or you can say a pattern. Okay. So uh, there is a term called estimation. So because of the randomness, I let's say I ask you what time do you wake up uh, on a given on an average. So now is the average also not a random variable? Let's say you're going to say I wake up at 6 o'clock in the morning. So is random variable also is the uh, average also not a random variable? So
It
basically,
can be if we see the per week average.
yeah, good. So, what we are saying is that we can't really find out exact value of the most of the things which are there around you. You can't just have a single value to a thing, or you can't be definitive about any particular value of a random variable. You can only estimate its value. Okay, so what's the difference between estimation and uh, you can say a definite value? Okay, and one is an estimate and another is a definite value. So estimate is so how do I estimate? Estimate आप हिंदी में बोलते हैं अंदाजा, okay, or a guess, or near value or approximate value like that. So how do we estimate? Let's say I want to find out average height of your class. How do I estimate it? Or average height of triple IT students. I want to find out. So how do I estimate? How can I estimate it? I want to physically measure, go and physically measure the height. So all let's say some of students are here at campus. Only those students are available. I can consider them as sample and get an estimate of that. Okay. When you go to, let's say you are doing, there is a marriage at your house. So you can't know the exact value of the expenditure that is going to be there, but you can estimate the expenditure. Okay. So most of the things, similarly, that goes in the production as well. In the production, let's say you are manufacturing something, you are manufacturing a resistor, or you are manufacturing a car tire. Okay, so you can only estimate that what is the average diameter of the car tire, or what is the average resistance of the resistor which is being manufactured. So that is the meaning of estimation. Estimation is a very essential part of the inferential statistics, or inferential statistics is totally based on estimation. Okay, now there are several terms when we talk about inferential statistics. There are several terms like population, parameter, sample, and statistic. These are four very important terms which we should be able to understand when we are talking about. See, this is all data analytics, what we are doing. And the use of data analytics in quality control is what statistical quality control is. Okay, so population. So population we can say is set of all items that possess a certain characteristic of interest. For example, we are talking about India. Okay, so height of average height of Indian male or average height of Indian female. So in this case, I am talking what is the population over here? Population is the Indian male population and Indian female population. Okay. Now, what is the parameter under consideration? The parameter under consideration of the population is height. Similarly, but can I get an estimate of this? Is it possible to know the exact value of this? Question to all of you. Can I know exact value of average height of Indians, male and female separately?
No, sir.
Why Yukta? Why not?
Maybe.
How Jaswant, can you? I mean, we got Jaswant that said maybe, Yukta said no. Anyone with yes? Okay, let's see both of your answers. Why do you say so? So, Yukta, can you tell why do you think that we can't find out average height of exact average height of Indian population?
Yes, sir, because it is impossible to find out the height of each and everyone in India. So the average will be different for different observations and experiments. We will not
Yeah,
get one exact value for all the surveys.
yeah, you are right in that sense. To add up, let's say we were talking about Indian adult, which is above 18 years. Okay, so you go to measure the height. While you are doing the measurement, someone is actually turning 18 at the same time. This is a practical implication. Let's say, there was another person. What was his name? He said, yeah. Uh, maybe who said maybe who? Someone has said maybe no.
Yes, sir.
Yeah. So just one, tell me why do you say maybe? Maybe means yes and no both.
Like, sir, we calculate the population in India for every 11 years. Like that, we can implement a website where they can update their height.
Do you think people will do that?
Maybe we. That's why I said maybe.
Yeah,
It's not a complete.
it's just not possible. So what do? We take out a sample from the population. So we draw a sample from the population over here, and it is subset of population. We say it is a representative of the population. It's like uh, there is a marriage and your family has to go, but for some reason they can't go, so they send you as a representative. Okay, similarly, you can't measure the height of the whole population, so you take a subset of the population, some sample, representative sample from the population, and then find out the average height of it. And then you say this is the estimate of the population height. Okay, this is so a sample gives you an estimate. Just like you go to purchase vegetables in the market. So there are some vegetables like beans, which you can't pick one by one, each one of the, or like peas. You can't pick every single pea with pot every time and check it. So you take out 5 or 10 from that and then see whether it is good or bad, and you make an inference out of that. So descriptive means you look at the face of them and check their statistics, and then you make an inference whether you want to purchase that or not. Same thing is happening over here. In the production also, we take out samples and we try to make an inference from that. So we from the corresponding to population there is a sample, and corresponding to parameter you have statistic. So corresponding to sample, if we are talking about what is statistic, again height of the people involved in the sample. Okay, so parameter is for population and statistic word is used for the sample. So pp and ss, you can always remember it like this. So parameter corresponds to population, okay, or the variable which is describing the population is the parameter, and the variable which is describing the sample is the statistic. Okay, so in here also we can say height, but if we are taking out a sample, it will be called as a statistic. And if we are able to measure the height of the whole population, find out average of that, so we say that's the average height as a parameter. Okay, so we go ahead. So the key terms which we have understood is population corresponds to the whole universe, and parameter corresponds to the summary measure about the population, and sample is portion of the population or subset of the population, and the summary measure about sample is the statistic. Okay, so we continue this thing. Now, here, if height is we are saying is the average height, we represent it by alphabet or by notation mu. Okay. Similarly, statistic will not be represented by mu, but it will be represented by x bar. So mu is a parameter and x bar is a statistic. Similarly, sigma is the standard deviation for the population, and corresponding to standard deviation we have S as a sample standard deviation. Okay, so we say we draw a random sample from the population. We draw a random sample from the population. Why do we do that? In order to estimate. So x bar is estimate of mu. And S is estimate of sigma. Okay. So we estimate mean and the standard deviation. Now, these random variables can be continuous or discrete. They can be continuous random variable or discrete random variable. So what is continuous random variable? So the variable that can assume any value in a continuous scale. For example, you can say current or voltage. These are your continuous variables, continuous random variables, you can say. And then you have discrete random variables like numbers, number of pieces per minute or number of heartbeats per minute. Okay. So these are discrete random variables. So when I'm talking about continuous, can you give more examples, all of you? All of you write one example of continuous random variable and discrete random variable in the chat box. Write all of you write one example of discrete and continuous random variable in the chat box. Yes, anyone? Guess most of you are busy in dinner. Okay, so now just one this height. Okay, number of fingers. So just one number of fingers are actually not random variable. Height is a random variable. It can vary from person to person. But generally, we won't say number of fingers are discrete random. They are not random variable. Neither they are variable. Can you give another example for discrete? Amount of ice in glass, continuous. Continuous. Heartbeat is not continuous, Varun, because uh, number of beats per minute. So it can be 71, 72, 73. Weight of students in a class is continuous. Discrete is number of defective products. Good. Yeah, that is right. Shubhangi is right in both. So only Shubhangi has given correct answer till now. Other people, Yukta says discrete is number of family members in a family. Yeah, that is right. And it is variable. It changes from family to family. Number of children in family, same thing. Anyone else? Uh, okay. So I assume that most of you have understood it. Now, we need to know one more thing, that is how do I measure? Means what are the scales of measurement? So whatever measurement I'm doing, okay, so you look around things, and without measurement, you can't get those things which are whatever is there. You got a laptop, telephone, table, everything involves measurement. Okay, so when I do measurement, I need to know how do on what are the scales available for doing measurement. Generally, we are mostly familiar with only one type of scale, which is ratio scale. So basically, there are four types of scales: nominal, nominal scale, interval scale, ordinal, rather ordinal. I'm going to write second. Nominal scale. Second is ordinal scale. Third one is interval. And the fourth one is ratio scale. Okay, so these are the four different scales of measurement. Now let's talk about nominal scale. What is the meaning of nominal scale? It's like if I ask you that uh, classify um the color of the floor of your house. Okay, so some are going to say white, some are going to say off white, some are going to say gray, some are going to say different, some are going to say mixed colors. Okay, so the data here, the data is labeled data, or it is a categorical data or non-numeric. There are several words to this. This is non-numeric. Okay, so here we can say one represents black, two represents white, three represents red, four represents. So we can anyway represent it by numbers, but these numbers are just representative. They are actually not measurable. Okay, so nominal type of data is a non-measurable type of data. Or you can say in your you can have several branches in engineering like mechanical, electrical, electronics, triple E, computer science. Okay, so these are several branches in the college. So it's a nominal data. Like if you got 200 students in your college, so you can classify them. You can write branch besides them, and then this becomes a nominal data. Okay, although you can assign numbers also. One means electrical engineering, two means electronics engineering, three means mechanical engineering. So you can give numbers to that, but does not necessarily mean that these numbers have any significance. Neither you can't apply the laws of algebra, not applicable. Laws of algebra are not applicable on nominal data. You can't apply it. Like if I'm representing 1 by black, if black is represented by 1 and 2 is representing white, so 1 plus 2 does not mean, what does 1 plus 2 mean? It means nothing. Or 1 plus 2 divided by 2 will also mean nothing. So you can't apply laws of algebra on nominal data. Okay. Then you have ordinal data. So as the name implies, ordinal data has an order. It has the properties of nominal data, but there is a order in it. Now in nominal data, there is no order like black, white, gray, purple. So what order do you can't have an order for the colors. Getting it? You also can't have an order for mechanical, electrical, electronics, except you can say we can arrange them alphabetically, but that doesn't signify anything. Getting it? But similarly, ordinal data, you may have, let's say, first year right, second year right, third year right, and the fourth year right. So there is, although it is non-numeric data, okay, it is a non-numeric, and also you can't apply laws of algebra on that. So let's say 200 students are there in a class, in a college, and then you assign first, every student has been assigned a year in which they entered, like first year, second year, third year, and what year they are spending in the college. So if you find out average of that, it will not give you, it will not mean anything. Or even if you add up all the years, first year, second year, third year, it will not mean anything. Okay, so or you can say first year is called freshies, second year are called juniors, and third year are called seniors. Okay, so there is an order in that. I mean, there is a hierarchy in that. Getting it? So you can arrange them in ascending or the descending order, but you can't apply the laws of algebra on that. So that is the ordinal data. Or you can have ranks, like a student coming first is first, second, and third. They have been arranged. So also the distance between them is not same. One and two, how distant first rank student and the second rank student, the distance between them with respect to the marks or any other variable need not necessarily be the same between second and the third as well. So ordinal data has that kind of properties. Then you have interval and the ratio scale. After this, I'll be asking you to send messages on WhatsApp, which will I'll count it as it will be counted in the evaluation part. So just be attentive. So interval scale and the ratio scale. Now, ratio scale has absolute zero in it, and interval scale does not have no zero. Does not have zero. No zero in the interval scale. Okay. So interval data is always numeric, like score which you are going to get, uh, or let's say something which can't be zero, like you say time can't be zero. Okay, you can say temperature can't be uh, absolute temperature, or absolute temperature can't be zero, or you can say height can't be zero. Height can't be zero. Hmm. So that is sort of an interval scale, or it is somewhat relative. For example, person A has scored 1500 marks, and person B has scored 1350 marks. Okay, so 150 marks is the difference between them. So when we are talking about relatively, how much ahead a student is from the other student. So we can say that there is no zero involved in this case. We can say that if it is both of them score the same marks 1350, then it is zero. Then it goes to a different, I mean, we say here relatively. So relatively one has to be better than the other. It's not possible for them to be equal. So we're just saying in that scenario. So there are many things around you see where there is no zero involved. Now another is the ratio scale in which there is a zero. There is an absolute zero in that. Okay, now we can consider the time instant of starting a machine. So when the machine is just started, time is zero at that time. So we that if we can assign it that way, the time is zero. Okay, or you can say uh, if there's a box and there are things kept in that. If you take out all the things, there is nothing in the box. So you can say it is zero. Okay, or you generally get ratio scale mostly in uh, discrete units. So this scale must contain a zero value that indicates that nothing exists for the variable at the 0 point, like distance, relative distance, relative height, rel- relative weight, and time. I mean, if you look at this way, that if you are not moving at all, then the distance covered is zero. If something does not exist, the height is zero. Something does not exist, weight is zero. Something that has not started yet, that time is zero. So if those kind of scales are there, then we have ratio scale. Okay. Now, right now, I ask all of you to give one example of each type of scale and write that in the chat box. And not in the chat box, but send in the WhatsApp. I'll give you 5 minutes to do that. All if you do that, and don't copy each other. Right? I'm stopping the recording now.